Hi everyone, it's Josephine here and welcome back to ResearchSetGo. Today we're learning about functions. This is part 2. So in functions part 1, we discussed what relations are, as well as how to use the vertical line test to figure out whether something is a function or a relation. In this video, we'll be looking at function notation as well as using Toolkit functions. So let's start off with function notation. I'm just going to make this equation here a little bit bigger. And as you can see on the left-hand side, the f with the x in brackets represents y, which from our previous video we know is our outputs. So if y is the output, then x must be our inputs. So basically what's happening is we are substituting a number in for x, modifying it or changing it by whatever other number there is. So in this case, we're adding 1 to the x, and then that will equal the f of x on the left-hand side. So that's how you would read it, f of x. Sometimes, however, instead of f of x, you could have different variables. So I want you to pause this video and figure out if you can read this equation here. How would you say it? All right, so you would read this as j of k is equal to the square root of k over 3. So now that function notation is done, so before we take a look at Toolkit functions, I just want to explain why they are important. So if you are given a graph of some sort, knowing these Toolkit functions can really help you identify what kind of function you're dealing with. On the other hand, if you're given a formula, you can easily draw the graph of it if you know the general Toolkit functions. So the first Toolkit function is called a constant function, where f of x is equivalent to c. C is the constant, so it stays the same every time. So if, let's say, c is 5, then f of 3 equals 5, f of 7 equals 5, f of even negative 1/2 equals 5, so it stays the same. That's why we're going to have this linear graph, and basically the x values will change, but the y values will always stay the same. That's why it has this linear shape. Next, let's take a look at the identity function, where f of x is equivalent to x. So basically what we're going to have is, for example, f of negative 1 is equal to negative 1. F of 9 is equal to 9. So this is going to give us an exponential graph, and it's exponential because it continues growing. Now we have an absolute function. In this case, f of x is equal to the absolute value of x. So absolute functions are represented by a number with 2 longer lines next to them. And if you're not familiar with absolute values, pretty much the sign doesn't matter. So if it's a negative number, it's going to turn into a positive number. If it's a positive number, it's going to stay positive. So in this case, the graph is going to look somewhat like this. And since it's an absolute function, the entire graph is going to be in the first 2 quadrants. Next, we have the quadratic function. In this case, f of x is equal to x squared. And this time, our graph is going to be a hyperbola because it's a graph. It's a curved line. Now, if you guess that the cubic one is x cubed, you are correct. And this, again, our graph is going to have a hyperbola shape. It's a curved line. The next Toolkit function, don't worry, we're almost there, is the reciprocal function. So we have 1 over x. Now this graph is interesting. It pretty much represents an asymptote where we have 2 of the same graph, but it's kind of reflected on the other side. So this is a bit of an interesting graph made with hyperbolas as well. Next, we have the reciprocal squared function, where if you guess that f of x is equal to 1 over x, you are indeed correct. So in this case, it's the same as reciprocal, but it's squared. And our graph is also going to have asymptotes, but this time they're in the top 2 quadrants of the graph. Next, let's take a look at the square root toolkit function. So f of x is equal to the square root of x. And in this case, we're also going to have a hyperbola-shaped graph. So it's a curved line. And last but not least, we have the cube root function where f of x is equal to the cube root of x. Okay, so the graph for this is again going to be a hyperbola. So I just want to recap what we went through in this video. First of all, we talked about function notation, which is going to be very helpful later on with understanding how things are going to be read and written. And then we also looked at toolkit functions, which again are going to be very helpful when analyzing graphs and converting between equation and graph form. You don't really have to memorize all the toolkit functions. It's just good to have a general idea of what to expect and what you're looking at when analyzing graphs. So in our next video, we're going to be looking at interval notation, which is going to be very helpful later on in our functions studies. And I just want to thank you so much for making it to the end of this video. Please like, share, and subscribe for more amazing content on ResearchSetGo. See you soon!